Let's look at some other properties of logarithms. We have 3 here. We'll go through each one and then we'll do an example using them. First one, we have, call this the product property, log base a of x times y. So here we have x times y in the argument of logarithms. We can write that as a log base a of x plus the log base a of y. For division in the argument, x over y, log base a of x over y is log base a of x minus log base a of y. And then finally here we have this so-called power property. I think it's the most important one. Log base a of x raised to a power r is r times the log base a of x. So we can take the power on the base here, this x, and bring it down as a coefficient of the log base a. All right. One reason we have these properties, or one use of them, is to expand a logarithmic expression like this one. Why would we want to do that? Well, as you can see, the argument of this logarithm is very complicated. If we expand it using these properties, we get a bunch of very simple logarithms at the end, and that's useful for other mathematical activities. So let's expand this. All right. So we have the natural log of the square root of x cubed times p times q to the 5th power all over e to the 7th. Now, the first thing we want to notice about the argument is that it is a quotient. So it is something over something else. Even though it's very complicated and there's a lot of terms in there, it's really just something over, it's really an x over a y, right? Some expression over another expression. And we can write that then as the log base a of the numerator minus the log base a of the denominator. So we can write the natural log of square root x cubed times p times q to the 5th minus natural log e to the 7th. All right. Now, we have the natural log of a product of these things, square root of x cubed, p, q to the 5th. We can use the first property to split that up into a bunch of sums of logarithms. So we'll have the natural log of this, natural log of the square root of x cubed, plus the natural log of p, plus again the natural log of q to the 5th. All right, minus, and now we have the natural log of e to the 7th. We'll recall that the natural log and the exponential function base e are inverses of each other. So if we take the natural log of e to the 7th, we're left with just the exponent, 7. All right, what else can we do to this? Well, notice that we have some powers. We've got a square root and a 3rd power here on this argument. We have a 5 on the exponent of q. So we can use this property to bring down the exponents. Let's look at the square root of x cubed. Square root of x cubed can be written as a fractional exponent like this. We know that the square root is 1/2 power. And then we can evaluate this by taking the product of these two exponents. So this is actually x to the 3/2. So what we have right here is the natural log of x to the 3/2. Now using this property, we can bring down that exponent as a coefficient. So 3/2 natural log of x. Okay, plus natural log of p. And then here we have a 5 on the exponent of q. We can bring that down as a coefficient as well. 5 natural log of q minus 7. All right, so our original logarithm can be expanded as 3/2 natural log of x plus the natural log of p plus 5 natural log of q minus 7.